Hi, this is Team Shatchakra, and here we are to present our idea on Indian version of Nagish App, which is a problem statement ID is 1717 on SIH, and our team ID is 17265. So, the already existing Nagish app is a communication tool designed to help individuals with hearing or speech impairments by providing the real time voice to text and text to voice translation. It is more focused on making communication more accessible and particularly for the people who have difficulty in hearing or speaking during phone calls. So during voice to text, when someone is speaking on the phone, the app converts their speech into text in real time, allowing the individuals with hearing impairments to read the conversation. And it is vice versa in terms of text to voice. That is, for individuals who have difficulty in speaking, the app enables them to type their responses, which are then converted into speech and spoken aloud to the other person on the call. The difference between Nagish app and our application is that our app supports multiple Indian languages and dialects and are user friendly, which has a simple interface, which is easy for navigation. And this application also supports offline functionality where basic translation can be done without any use of the internet, which is very much useful in case of areas where there are less where there is less internet connection. Coming to the technical approach or workflow, first enter into the app. You start by entering to the app, and then the app asks for permission access such as microphone permission, storage, internet, speech recognition permission, and text to speech permission, as well as network access. And then the user can select any language of their choice in which they are comfortable in communicating with the other person. In the workflow, the plain text boxes are at the end user, and the colored boxes are for the technical approach and are not directly integrated with the user. And now, coming to the VoIP integration. VoIP stands for Voice over Internet Protocol, which helps in incorporating the ability to make calls and receive calls over the internet into an application or system instead of using traditional phone networks. Now the user can dial the number and call so that he or she can communicate. The user can select if the input given by the user is in the form of speech or text. And there are two modes, one is offline mode and the other is online mode. The offline mode uses TensorFlow Lite packages, whereas online mode uses Google Cloud API. The Google Cloud API uses real-time speech recognition, which converts speech to text in real time, and are useful for live transcription or voice command features. And it also supports multiple languages, especially Indian languages. Recognizes over 125 languages and variants. Variants include the dialects of the user. It can also filter out the background noise to improve the voice recognition. TensorFlow Lite can be used to perform voice to text and text to voice on mobile in offline mode by using pre-trained machine learning models, which are optimized for low power and limited resource environments. So for converting voice to text using TensorFlow Lite, we can use pre-trained speech recognition models such as recurrent neural network, which are already trained beforehand and and converted into TensorFlow Lite format to run on mobile devices, which converts the voice to text. Whereas for offline text to speech functionality, TensorFlow Lite can use models like WaveNet to synthesize speech from text. These models are trained to convert written text into speech like features. And the TensorFlow Lite packages is directly connected to the on-device processing, where on-device processing is connected to privacy end-to-end encryption. Because when the data is processed on the machine, there is more increase in privacy. and leading to the language dialect detection. It detects the type of the dialect or that the person is comfortable with. Now the sound is converted into from analog to digital signal, and then with the pre-processing in the pre-processing, noise reduction happens, where the other noise which is captured during communication is removed. The acoustic model is trained on large datasets of audio recordings and their corresponding transcriptions. So this training helps the model learn how different sounds are represented as waveforms, and the language models are used to predict the sequence of words, which are again pre-trained and are predicted using these models. Now these are converted back into the text, and that is given to the user and displayed to the user. So the privacy is ensured using HTTP with TLS 1.2, and again on-device processing while using offline mode, which is TensorFlow packages. The processing happens on the device, so there is no data that goes outside the device, and hence privacy is very much ensured. The basic tech stack for building this application is provided here. Coming to the next slide. Coming to the feasibility analysis, the project is very much feasible according to the idea presented, because the Nagish app is already existing. The only thing is that we have to add an extra feature that accepts multiple Indian languages, which can be done using Google Cloud APIs and TensorFlow Lite as mentioned above. It has high market demand, which is very much essential for individuals with hearing and speech impairments, and it works offline, which is again by using TensorFlow Lite. It has very much a user-friendly design and has strong data privacy. The potential problems have already been discussed in the workflow. For example, privacy is ensured using HTTP PLS with 1.2 and on-device processing, offline functionality using TensorFlow Lite, and accuracy can be obtained by Google search, Google speech to text search engines, because Google API has advanced trained models, and it has higher accuracy. And for integrating voice communication via internet, we have used VoIP integration, which solves the problem. Coming to the impact and benefits, the impact on audience is that it supports native languages. It is accessible in remote areas due to offline functionality. It gives awareness and inclusiveness to the society, for the people who are suffering with disabilities, and independent communication for individuals with hearing and speech impairments, because the people now can independently communicate and not depend on anyone for communication. It improves the quality of life of the people suffering with these disabilities. It provides economic opportunities and participation, as uh, they can overcome such a major problem which is faced by them in day-to-day life. There is less paper usage, which reduce carbon footprint, as all the transcription happens on the mobile without the use of any paper. It can improve social interactions for the people facing with such disabilities. Now they can easily communicate without thinking beforehand and without depending on anyone with other people. As the Indian languages are implemented in our application, it helps in cultural preservation, and they need not go to other language to need not learn to communicate in other language by facing such problem. So these are the reference links that we have researched while trying to solve this problem statement. So, developing such an application that successfully converts voice to text and text to voice in multiple Indian language dialects is a significant achievement, addressing a crucial need for accessibility, inclusivity, and multilingual communication in a linguistically diverse country like India, and would solve problems for the people who are facing many problems in day-to-day life. Thank you.